Okay, in the next few videos we are going to talk about an important class of graphs called planar graphs and their properties. Okay, suppose that we are going to draw a graph on a paper. Okay, so it will look something like this. Suppose that we are going to draw say K4 on a sheet of paper. So one drawing it could be something like this. So in this case we can see that if you look at this particular drawing, okay, here we have what is called an edge crossing. Okay, but here we can see that we could draw this particular graph. Okay, in this case we have this K4 in a different way, in such a way that there is no edge crossing. For example, okay, one possible drawing could be something like this. Okay, so we have this cycle, okay, and this, okay, and these two edges. So now we can see that there is no edge crossing, and we can draw, okay, the remaining edge something like this. Okay, so here we can see that if you look at this particular K4, okay, again we have this K4, because there is no edge crossing. So that says, okay, we can draw K4. Okay, so we can K4 can be drawn with no edge crossing. Okay, so here we have these two drawings of K4, one with an edge crossing and another without an edge crossing. So this leads us to two important definition of what is called planar graphs and plane graphs. Okay, so let me give the definition of a planar graph and a plane graph. So a graph G is called a planar graph if it can be drawn on a plane without edge crossings. Okay, and that's what we saw in the previous slide. Okay, for example, I redrew the figure here. So we can see that, okay, this particular thing of drawing, okay, this K4 drawing has an edge crossing, but we could redraw in such a way that there is no edge crossing. Okay, so that says this K4, a complete graph on four vertices, okay, is a planar graph. Okay, so that says we could draw K4 in a plane in such a way that there is no edge crossings. Okay, so a graph is called planar graph. It can be drawn on a plane without edge crossing. Okay, so without edge crossing, so that says K4 is a planar graph. So another important definition is what is called a plane graph. A graph that is drawn on a plane, okay, without edge crossing is called a plane graph. So it's a drawing of a planar graph, okay, in such a way that there is no edge crossing. So here we have two drawings of K4, okay, but if you look here we can see that we have this edge crossing. So even though K4 is a planar graph, okay, this drawing, it is not a plane graph. Okay, whereas if you look here, okay, it's another drawing of K4, but here if you look into this particular drawing, we can see that there is no edge crossing. Okay, so this is a plane graph. Okay, so remember, a graph G is called a planar graph if it can be drawn on a plane without edge crossing. Okay, so okay, here we can see that K4 can be drawn on a plane without edge crossing. Okay, so that says K4 is a planar graph. So a planar graph, it could be drawn in many different ways, something like this and this. So a graph that is drawn on a plane without edge crossing is called a plane graph. So even though K4 is a planar graph, because this particular drawing is not a plane graph, whereas this particular drawing is a plane graph of K4. Okay, so I think the definition is clear now. So let's look at some other terms related to planar and plane graph. Okay, so before that, let's look at one or two examples. So let's look at this K23, a complete bipartite graph with two vertices on one partite and three vertices on another partite. Okay, so this is one drawing of K23, okay, but it is not, okay, it is not a plane graph, okay, but it is a planar graph, okay. So that says we could redraw this particular graph in such a way that there is no edge crossing, okay. So let's try for this one. So here we have, okay, these three edges from x1 to y1, x1 to y2, and x3 to y3, okay. So we are trying to draw a plane graph kind of thing, okay. You are not allowed to cross edges, okay. So I think we could add this edge from x2 to y3, and we need to add two more edges here between this x2 and y1. So we could draw something like this. We could introduce this edge in this way, and we could introduce the other edge in this way, okay. So this is another drawing of this graph K2 3, okay, and this is a plane graph, okay. Here we can see that no edges crosses each other, okay, and that says this K2 3 is a planar graph. So a graph is said to be a planar graph if it can be redrawn on a plane in such a way that no edges cross, okay. And such a drawing of a graph in which the edges do not cross is called a plane graph. So even though K2 3 is a planar graph, this particular drawing is not a plane graph, okay. So this is a drawing of K2 that is a plane graph. So let's look at one more example, okay. So let's look at this particular graph, okay. It looks almost like K5, but it is not K5 because we can see that there is no edge between this A and C, okay. So again, this is not a plane graph, okay, but it is a planar graph, okay. Let's try to find a drawing, okay, that is a plane graph for this one, okay. So here we have this cycle, so that says these 5 edges will be there, okay. So far everything is okay, there is no crossing. So let's add these two edges, okay, from between A and D, and okay, and say B and D, okay. So far there is no crossing of the edges, and we are left with two edges, this one and this one, right, okay. So we can draw that, okay, that between E and B in this way, okay, and E and C in this way, okay. So now we have a plane drawing of this particular graph. So we can see that this is a plane graph, okay, and that says this graph, okay. Let's call this graph G, okay. G is a planar graph, okay. So that's the definition of a planar graph and a plane graph. A graph is called planar graph if it can be drawn on a plane without edge crossing. A graph that is drawn on a plane without edge crossing is called a plane graph, okay. So let's look into one more term related to planar graph. So here we can see that a plane graph divides the plane into different regions, okay. For example, if you consider this particular graph, okay, that is our K4 graph, okay. So this K4, it divides the plane into different regions, okay. So this is one region, okay. Let's call that region R1. So this is another region R2, and this is another region R3. Again, we have this outer region also, okay. It's an unbounded region, okay. So in this case, we can see that these regions R1, R2 and R3, okay, they are bounded, okay. They are bounded by, okay, these edges. So that says these regions R1, R1, R2, okay, R1, R2 and R3, okay, they are bounded regions, okay. They are bounded regions, okay. Whereas if you consider this R4, so R4, okay, it is an unbounded region. So R4 is an unbounded. And here again we can see that if you look at any plane graph, okay, any plane graph has an unbounded region, and that particular region is called an exterior region. So we can very easily see that every plane graph has an unbounded region. Okay, and it is called the exterior region. Okay. So in this case, this particular region R4 is what is called the exterior region. It's an unbounded region, and every plane graph has an unbounded region. Okay, so let's look into two more examples. Okay, so let's consider this graph G and this graph T. Okay, T is a tree anyway. Okay, so here we can see that if you look into this graph, again we can see that it divides the graph into different regions. Okay, so here let's call this region R1. Okay, so here we can see that this R1 this region to include this particular edge. Okay, R2 is this region, and R3, okay, this unbounded, the exterior region. So here in this case R1 and R2 are bounded region or interior region, and this R3 is called an exterior region. Okay, so if you look into this particular graph T, okay, which is a tree, okay, here we can see that, okay, it has only one region, okay, this exterior region. So every tree has only one region, okay, and that region is going to be an unbounded one, okay, and it has only one exterior region. Okay, so that is a plane graph divides the plane into, okay, regions. I think the notion of regions is clear. Okay, and then we can talk about what is called a boundary of a region. So a boundary of region in a plane graph is a set of vertices and edges that outlines it. Okay, so it's a set of vertices and edges that outlines it. Okay, so let's consider this particular graph and this particular graph. Okay, we can see that, okay, these two graphs G1 and G2 are isomorphic. Okay, but okay, they have, okay, two different, okay, they are two different plane graphs. Okay, so we have two different plane drawings here. Okay, so that says this G1 and G2 are, okay, this G1, even though they are isomorphic, G1 and G2 are different plane graphs. Because they have a different planar embedding or planar drawing. So here we can see that this edge goes out of this particular thing, and here this edge lies in the interior of this thing. Okay, so here if you label the regions as follows: R1, R2, R3, and similarly here also R1, R2, R3. Okay, in this graph, okay, we can see that this R2, okay, this R2 contains these edges, okay, these three edges and these three vertices. Okay, so let me use a different color for that. Okay, so if you look at this R2 in this graph, okay, so this R2 is identified by, okay, this vertex, this edge, this vertex, okay, this edge, this vertex, and this vertex. So whereas if you look here, okay, if you look here, okay, here we can see that this R2, this region is identified by this vertex, this edge, okay, this vertex, this edge, and this vertex, and this edge. Okay, so here this R2 is identified by, okay, this particular thing. Okay, these 1, 2, 3, 4 vertices and these 4 edges, whereas in this case this R2 is identified by the, okay, this vertex, this edge, this edge, this vertex, and this vertex. Okay, so that says the boundary of a region in a plane is the set of vertices and edges that outlines. Okay, and that says, okay, here okay, for these two graphs, okay, if you look at R2, so this R2 is identified by, okay, this vertex, this edge, this edge, okay, this vertex and this one. Okay, so we can see that even though these two graphs are isomorphic, okay, they are entirely different, okay, plane graphs. So that says the boundary of a region in a plane graph, okay, the set of vertices, and that boundary is identified by the set of vertices and edges that outlines it. Okay, similarly, the region R1 is identified by, okay, this vertex, this edge, this vertex, this edge, this vertex, and this edge. Similarly, here R1 is identified by, okay, these vertices and these edges. Okay, and R3 is again identified by, okay, these outer edges and these outer vertices. So here we can see that this R3 it will include, okay, this edge and this vertex also. Whereas if you look at this particular graph G2, okay, this R3 does not contain, okay, this edge and this vertex because it is interior to R2. Okay, so the boundary of the region in a plane graph is the set of vertices and edges that outlines it. Okay, and similarly, we can define what is called a non-planar graph. So a graph is called non-planar if, okay, it is not planar. So that says, okay, it is not possible to redraw that particular graph without edges crossing. Okay, so let's look at one example of such a graph, and I will give an informal proof here, and we will formally prove that in a later video. Okay. So here, okay, if you look at this particular graph, we can see that, okay, this graph is nothing but a complete graph, a complete bipartite graph K33. Okay, so the fact is that this K33, a complete bipartite graph where one partite set has 3 vertices and another partite set has 3 vertices. So I labeled the vertices on one partite, one part as blue and another part as red. Okay, and fact is that K33 is non-planar. Okay, so let me give an informal proof for this thing. So we will formally prove that K33 is non-planar in a later video. Okay, so here we can very easily see that, okay, this particular graph, it has a Hamilton cycle. Okay, for example, you can go from here to here, then here to here, here to here, okay, from here to here and back. Okay, so very easily we can see that this K33, okay, it has a Hamilton cycle. Okay, and K33 it has 6 vertices, so I am going to try to draw this particular thing in such a way that the edges do not cross each other, and we will see that, okay, I won't succeed in that particular attempt. Okay, so K33 has a Hamilton cycle, so it has 3 plus 3, 6 vertices. So since it has a Hamilton cycle, okay, it should have, okay, this cycle, okay, C6. Okay, and okay, this particular thing, it has 1 2 3 4 5 6 edges. Okay, so here we have 9 edges. Okay, number of vertices is 6 and number of edges here is, okay, 3 into 3, okay, 3 times 3 is 9. So okay, we use 6 edges in this cycle, and so we are left with okay, so we are left with 3 more edges. Okay, so one between this green vertices and the other vertices. Okay, so let's see what is going to happen, and suppose that, okay, so here we can see that, okay, this particular cycle, it partitions the region into the plane into 2 regions, R1 and R2. Okay, okay, so we are left with 3 more edges here, right? So let's try adding those edges. Okay, so in this case we can see that we can add, okay, this edge violating any condition. Okay, So that's divides this particular region into two region. Okay, let me call that as R11 and R12. Okay, so after that we are left with two more edges. Okay, so we can add, I think, one more edge here between this one and this one. So here we can say that if I add this edge in this way, we have this crossing. Okay, so that is not allowed. Okay, so it will cross this one, so we should go through this region R2. Okay, so far so good, and we added 6 plus 2, 8 edges, and we are left with one more edge. Okay, so here again we can see that this divides this R2 into two regions. Okay, let's call that R22 and R21. Okay, so now we are left with two edges. Okay, so that says either we have to go through this inner region or through this outer region. So we want to add that between this red vertex and this blue vertex. So if we add this way, we can see that there is a crossing here, so that is not allowed. Okay, so we are stuck. Okay, similarly we can see that the other possibility is we can go from here to here using this outer region, right? So here again we can see that if you go that way, we have a crossing and we are stuck. So in both cases, we can see that we got stuck. Okay, and that says it is not possible to redraw this particular graph K33 in a plane without edge crossing. Okay, and that says this particular graph K33 is not planar. Okay, and here let me give the argument why this does not work. So by the pigeonhole principle, we have two edges. Okay, so here we have we consider the middle region here. Okay, this particular thing or this particular thing. Okay, we can see that we need to we can see that there will be two edges. Okay, that passes through this region or this region. Okay, so we have only one region and through two edges. Okay, and by pigeonhole principle they must intersect. Okay, let me write down that particular thing. So here we can see that by the pigeonhole principle, by the principle pigeonhole principle we have two edges. So this one and the other one that we want to add to build this particular thing. Okay, we have two edges. Okay, both going across the middle of the Hamilton cycle. Okay, so this particular edge. Okay, so that is not allowed, or both going across the outside region. Okay, across this Hamilton cycle, or maybe this particular thing. Okay, both going across the middle of the Hamilton cycle or both going across the outside of the Hamilton cycle. Okay, so we have only one kind of region and two edges. Okay, this one and this one, or maybe this one and the other one. Okay, or both going across the outside of the Hamilton cycle. Okay, so this particular thing. So if in both cases we can see that there will be a crossing here. Since we have only two region and two edges, okay, that need to cross that particular region. Okay, so by pigeonhole principle, Okay, both of those edges will cross. Okay, one situation is something like this, and the situation is something like this. So in both cases we can see that, okay, we get stuck, and that says, okay, so it's only an informal proof. Okay, we'll prove this formally in a future video. Okay, and that says, okay, there will be an edge crossing. So there will be an edge crossing. Okay, so K33 is non-planar. Okay, another example is, okay, this K5. Okay, K5 is also non-planar. Okay, anyway, we will formally prove K33 and K55 they are not planar. And okay, these kind of graphs, okay, they are very important with respect to planar graphs. Okay, so we'll see when we discuss one important theorem that characterizes planar graphs called Kuratowski's theorem. Okay, so in a later video we will prove K33 is non-planar and K5 is also non-planar. Okay, so in this video we went through the basic definitions of what is called a planar graph, a plane graph, then the notion of what is called a region and the boundary of a region. So in the next few videos we will look at some properties and an important characterization for planar graphs.